My name's Bill Tredik. As he mentioned, I'm the Indian River Lagoon Protection Initiative leader, also the Northern Coastal Basins Initiative leader. And I want to thank the United Waterfowlers of Florida for the opportunity to talk a little bit today about the C1 retention area, or excuse me, the C1 rediversion project, which part of that is the C10 reservoir, which I'll talk about later, and the Sawgrass Lakes, which I think Hector talked about briefly. So I'm going to try to move fairly quickly because I probably brought too many slides here. Back in 2013, the Water Management District developed in their strategic plan. They put together 10 strategic initiatives. A few of those are on the screen here. I'm not going to list them all. A lot of them have to do with water. But springs protection was an important one. Upper Basin, which Hector's in charge of now, that's an important one. One that overlaps with the Indian River Lagoon Protection Initiative, which I'll talk about in just a little bit, because it's that overlap that really is what we're trying to deal with rediversion. But before I go into that, I want to just real quick talk about the Protection Initiative, since it is what I do. And I won't read the whole vision statement, but the first three words, protect and restore, are extremely important that we all keep that in mind. We're committed to providing a healthy ecosystem, abundant in wildlife, all sorts of wildlife, fish, waterfowl, other birds, crustaceans, shellfish, the whole 9 yards. We're trying to make the ecosystem better out there for the Indian River Lagoon. And as all of you probably know, we have a lot of challenges. The Indian River Lagoon had a series of algal blooms starting in 2011, which caused a lot of damage. In 2011, we had a super bloom, as we called it, resulting in a lot of problems, a lot of seagrass loss. We have habitat degradation throughout the Indian River Lagoon, from mosquito impoundments, dragline ditches, where 70% of the salt marsh has been lost over most of it in the 1950s and 60s. Water quality is something we've got to work on very closely with the initiative, stormwater treatment, and that's where I've got highlighted the water diversions. I'll come back to that in a second, but communication is vital. That's what I'm here today for. We've got a lot of things happening in the lagoon right now. We've got money flying from different sources, from the state, from the federal government. Got to make sure we're all working on the same page, going in the same direction. It's absolutely vital. But water diversions are what we're here to talk about today. The Fellsmere Main Canal, which Hector might have talked about a little bit in his presentation, was built, actually started in the late teens and built in the 20s. C-54, the Melbourne-Tillman Canal, a little further north in Palm Bay, was built roughly the same time. Both of these were for agriculture to drain the land. The problem was the best land for farming was the floodplain of the St. Johns River. The soils are great for farming, so they ditched through there, drained it out to the Indian River Lagoon, and in fact it worked so well that they wanted to do more in the 1970s. Actually, starting in '69, the Army Corps dug the C-54 Canal, which put even more water out into the Indian River Lagoon. But we're here to talk about C1 right now. If you look at, I don't know how well the green and yellow show up right here. You can see the area in green. The black box is the Melbourne-Tillman Water Control District. The area in green is part of their district that used to drain to the St. Johns River. If you look at the way it is now, all of this is turned yellow, all of this area, and this is a 100 square mile area. Almost all of that 100 square miles goes out to the Indian River Lagoon now instead of the St. Johns River. And that's what we're here to talk about, and that's what the rediversion effort's all about. But what's wrong with that? What's the problem with putting the water? It certainly helps flood control. It gets the water out of there in those events. But what's in the water? First off, what's not in the water? There's no salt in the water, or very little salt, I should say. There's coloration, there's turbidity in the water, and maybe most importantly, there's a lot of nutrients in that water. And what can that do? Well, you see the graph on the top, the salinity impacts. This is just one little slice of time after an event. And you can see how the salinity drops off. It plummets when these surges of fresh water move out into the lagoon. Clarity drops. You look at the next picture, you can see the line real clearly where the clarity is. Some of that's tannin, but there's also suspended solids in there. There's a lot of things that are very bad for the water clarity. and they contain some of the material that ends up here, the muck. We're about to spend $20 million, though the state is going to spend 10 this coming year on dredging at the O'Galley River. 625,000 cubic yards of muck will be dredged. I mean, it's an expensive thing to remove that muck. Those sediments that are in suspension cause those mucks, and the discoloration and the sediments that are in the water can lead to the seagrass loss. Now, that's not what caused our seagrass loss that we had in 2011 and 12. The algal blooms did that. They shaded the light. But turbidity is another factor in that. Turbidity and algal blooms together, that's even more shading. When the light doesn't get to the seagrass dies. You can see this is a picture of the brown tide, the algal bloom that happened for 2 years in a row. And all of this has a tremendous impact on wildlife. The ecosystem's in distress. There's no doubt about it. We're trying to figure out why, what we can do about it. And the bottom line is we want a healthy ecosystem that everyone can enjoy. So what's the answer? The answer is really to try to put as much water as we can back where it came from, or back where it should go, I should say, back to the St. Johns River. But it's not easy. There are a lot of challenges. There's flood control issues. There's a lot of population growth, a lot of density in the Palm Bay area. There's downstream growth along the St. Johns River. So there's all these people have to be considered. The last thing we want to do is impact them in a negative way in relationship to flooding. There's base flows to the Indian River Lagoon. Yes, we want to cut down on the fresh water, but we can't take it out completely. It is an estuary. It depends on fresh water to keep the balance of salt and fresh appropriate. So it's absolutely essential that we keep some fresh water flowing through these natural tributaries like Turkey Creek. The water quality in the St. Johns River. We can't just put the water in the river. We've got to treat it first. And I heard the word Sawgrass Lake. Hector came up in the comments. I'll talk a little bit about that in this presentation. Sawgrass Lake is a perfect example of a treatment area that does a really good job. As Hector also said, it's pretty new, so it's got a lot of nutrient uptake capacity right now. But we've got to treat that water first, and economic. I mean, that's the one that hits us all. These things cost a lot of money. The C10 project that I'm going to talk about towards the end is probably going to cost between 12 and 15 million to build. And that's just the construction cost. All the other work that's been done is in the tens of millions. The long-term costs are there too. We're going to be pumping essentially forever, which costs money, costs electricity. All these things are long-term costs, and we have to be able to sustain it into the future. So real quick, the timelines, I'm going to go through some of these kind of fast because I only have a half hour, but 1928, 85% of the slides were done. Not a whole lot happened. We had the Depression, you had World War II happen. There was I think they trained out there on airstrip right near the C1 canal. So not a lot happened until 1960 when General Development bought it and started to think about turning it into residential, more urban. In that first time, there was never a weir put in on this canal. So these canals flowed straight out to the Indian River Lagoon for all those years without any sort of control. And in 1978, when the weir and lock was completed, I don't know all the history of that, but I assume that they had concepts that involved navigation to and from the lagoon, which didn't really pan out. So the lock went unused. And in 1994, the SWIM plan, the Surface Water Improvement and Management Plan, came out. And that's the first real document that addressed rediversion and trying to target putting some of this water back into the river. Just a quick picture of a composite of 1943 aerial. This is the oldest aerial I think that exists of the region, aerial photography. You can see all this land in Palm Bay is pasture, open water. There's the old, I think it was an Air Force training airport during World War II. The canals were dug in 1943, but not much was used other than agriculture. And you go look at it, what it looks like today, it's a little different. And that changes everything. Even though the canals were there, the way the water gets there is different. It's a lot flashier. That means, impervious surface, it goes into the ditches and in the canals a lot more quickly. There's a lot more turbidity to that water. There's a lot more nutrients. Especially with fertilizers, with septic systems. A lot of these homes, I think most of them in certain areas are on septic still. So there's a lot of things going into that water. It becomes even more important that we redivert that. So rediversion got some traction. In 2005, this was a conceptual plan. If you look at these areas here, this is where the C10 is going to be. At the time, it was called the C1 detention area, I believe, because they didn't conceive of it as a reservoir at the time. It was just a low area where flooding occurred. So the district determined, instead of trying to mitigate, find a way to make that work, it's better to acquire that property. A lot of things about this didn't work from a flooding standpoint. The district went through multiple operations, simulation after simulation, to try to find a system that worked best. You look at all these red dots, these are all areas where there's flood problems associated with the models, where I don't even know what all of them are. I know what the one we fixed in the final model is. A lot of them were conveyance problems, canals weren't big enough, intersections flooded, things like that, with the changes that we were proposing. So we finally settled on this one, which only had one area that needed to be addressed, right there at Hurley Boulevard, or Hurley Road, and it was a pretty simple repair. So from that standpoint, we found a project that worked. It has all the components that we've come to know, the Sawgrass Lake water management area up here, C1 canal, the MS1 structure, which existed before, but was modified, which I'll talk about in a minute. That's where we did the improvement, and this will be the C10 reservoir. So real quick, I'm going to do a brief discussion of the phase one, which is complete. It consisted of several things. The MS1 structure that was built in '78 was a different kind of structure. The gates opened at the bottom. It was called Amil gates, A-M-I-L. I don't even know exactly what that stands for, but the gates opened at the bottom, so anything along the bottom, the sediments that were at the bottom, they flush right out into the lagoon every time the gates were open. It had, we had to put in pump stations out west to get the water into Sawgrass Lake. The river's higher out there, so we can't gravity discharge in and still provide flood protection. We have to get it up high enough so that it can gravity in. We had to make an outfall structure out of that Sawgrass Lake water management area. We had to do that Hurley Road improvement, as we mentioned. And lastly, the MS1 operation had to change. And I'll talk about that a little later. The benefit of this project was that 28% rediversion. And what that means is that's 28% of the average annual rainfall now goes back to the St. Johns River instead of out to the Indian River Lagoon. It's by no means what we want. We'd like to have a lot more than that, but it's the first step. It's the first phase, and out of it, more than a quarter of the water. And this year, we got even more than that because it was such a wet year. They've been pumping nonstop all year, all summer. The benefits to the IRL are substantial. The salinity stabilizes. You still get your slugs of fresh water and storm events. You can't do anything about that, but your nutrient loadings are lower, your sediments are lower coming in. In fact, one of the problems Melbourne-Tillman's having now is sediment. It used to just go out into the Indian River Lagoon. Now it's stuck behind MS1 because we replaced it with a different kind of gate, and we're working with them on that. Water supply benefit. When we came up with this project, water supply wasn't really something that was considered, but now it is, because water supply has become a more and more important issue. We've got, I think, 4 of our 10 initiatives deal with water because the need for water is going to be so pressing in the future. So this could give us some help in that regard. And it captures a mean annual storm. That's 2.3-year event, and what that does is the gates don't open. It totally holds that back minus whatever's flowing over the gate. That's a huge improvement over the past. I'm going to fly through these pretty quick because I know I'm short on time. The Hurley Boulevard was a pretty simple improvement. The culverts were replaced to improve the flow. The district funded it, but Palm Bay constructed it. That's now done. The Sawgrass Lake Water Management Area, Pump Station 1. You can see where it's located on the inset. It's on the west end of the C1 canal. It's designed to bring the water into Sawgrass Lake and have it treated in the southern cell of Sawgrass Lake. That's operational now. It's been running pretty much nonstop all summer, except for a brief time when we had a problem with one pump, which is now fixed. The North Pump Station up in the north end of Sawgrass Lake pumps from the C2 canal in, and you can really see how turbid the water can be at times that's coming in. It's kind of got that brown color, and since it's just come in, it hasn't been treated yet. But as you go towards the outfall, which is down on the southwest corner, the water quality, I was out there about a month and a half ago, and the water was so clear coming out that outflow structure. It's amazing. By the time it gets there, it just loses almost all of its turbidity. In fact, I didn't notice any turbidity visually. Nutrients are reduced, and some of that's because it's new, and the growth has been phenomenal in the last couple of years. But it's an amazing system. And this is an aerial shot of the Sawgrass Lake water management area. It's a couple years old, so it's actually quite a bit greener than that. It's grown a lot since then. But you can see in this picture, the north pump station's up here. There's a diagonal berm. That pumps into there, and it goes through some culverts. It gets treated, and it goes through some culverts into the central area. Excuse me. The south pump station pumps into the south cell, which is divided by a berm here, goes through culverts into the central, then goes out and down to the St. Johns River from the outfall structure. And this system is working incredibly well right now. Got ahead of my notes here. So what's next? The C10 reservoir. This phase 1 is working well. There's been a few bugs in it. Melbourne-Tillman Water Control District had some concerns that we're working with them on. They've had some impacts due to the higher water levels, and I'll talk about those levels in a second. But what's next? The C10, I think I skipped that one. Let me back up here. The MS1 structure, I wanted to talk about that briefly. This is what it looks like now. It looked very different before. And I mentioned the operation schedule issue. You can see in the past it was at elevation 4 all summer. So whatever came went out to tide. Elevation 8, they'd raise it up during the winter. And then the new operation has it at elevation 10 all year. And the minimum flow is what's important. Not just does it hold it, it doesn't just hold the water at 10, but as we hit a dry period, the water levels start to go down in the canal. The gates gradually open to keep 25 cubic feet per second flowing out into the lagoon to address those minimum flows we're talking about. We have to keep the water level that high so that we can pump on the west end. It's that simple. The higher we can keep it, the more we can pump. So it's this delicate balance of keeping the water levels up, pumping into the St. Johns River, and not causing flooding. So that's the tricky thing that we're working out with Melbourne-Tillman Water Control District right now. And we've developed a pretty good partnership with them. All summer, though, until just recently, they're opening it for some maintenance, but all summer they've been at elevation 10, actually closer to 11. We've been pumping like crazy. So the C10 reservoir, you can see this is the next step. I circled it in red here. All the other components are built. This is the last component that has to be built. And I like to think of this in a way as a mini Fellsmere, because it's very much like the Fellsmere water management area, except on a smaller scale. Fellsmere is 10,000 acres. This is 1,300 acres. But the topography is very similar. Up here you've got elevations 20 to 21, and down here you've got elevations around 14 to 15. So when this is flooded, it's going to have a very similar ecosystem. It will have a lot of open water. It will have some emergent and transitional wetlands. And depending on the final stages that are selected, it may even have a little bit of upland in the top corner. So from a wildlife standpoint, it should provide the same kind of benefits on a smaller scale that Fellsmere provides. It's going to consist, at least the current plan, it's in the conceptual stage, right? Actually, conceptual stage is done. It's in design. This is a levee construction similar to the Fellsmere levees. This is the federal flood protection levee that will have to be benched for erosion control. We'll pump water in from the Melbourne-Tillman's C9R canal, and it'll probably come out either here or here into the Three Forks Marsh Conservation Area. I don't think this is going to happen up here, but that's not certain. That was just an outfall for potential flows up north, but the modeling will determine whether that piece is necessary or not. So as I said, it's a 1,300 acre reservoir. This gets us a lot higher. This gets us from the 28% I mentioned a minute ago. It gets us up to close to 43% of the mean annual rainfall gets put back in the St. Johns River. We're getting very close to our goal of 50%. And something we're trying to do here is, I talked about those pump stations a minute ago. They were each designed with an empty pipe going through the levee. So we're also adding 2 additional pumps out there to bring the total capacity, increase the pump capacity by 100 cubic feet per second. So we're going to be pumping, hopefully be exceeding the 43 once everything's operational. The sediment nutrient removals will be incredible for the Indian River Lagoon. They're going to help tremendously. And this gives us even more water supply benefits. It also gives us a reservoir, hopefully we can draw down from to keep minimum flows going in drier times. And recreational opportunities. Hector mentioned the walk-in use and the non-motorized. I think we're going to be looking at something very similar for this project with not the motorized boats, no airboats, but walk-in recreation. Potentially, it will almost be exactly as the way Sawgrass Lake is managed right now. So I think that provides benefit for everyone. I mentioned the levees, 4 miles of levees, a lot less than Fellsmere, but it's still a fair amount of levees. It's going to have a big pump station coming in. We're not sure of the size yet, but it may be as much as 300 cubic feet per second. That will be located on that south end. It will have an outfall structure, as I mentioned, and we're still working on what kind of internal improvements are necessary. We're doing all sorts of wind wave analysis, just like we did on Fellsmere, but on, it's funny that the project's smaller, but the effort's about the same because you've got to do all of this homework to make sure that you're not causing problems. You've got a town there, you can't overtop that levee and risk residents. It's going to be a high hazard classification because of Palm Bay being there, and so we have to take all of that into consideration. As I mentioned, design is underway. It's going on this year. We're hoping to have design far enough along in sometime in early spring to move into the permitting phase to get our permits submitted to the Army Corps of Engineers, and construction beginning in fall of 2015. It looks like it's about a 2-year construction project. That's probably optimistic. It may be a little longer because you always have things come up. We found that out in Fellsmere. We thought we were going to be done a little earlier, and reality set in, and we're back to our original schedule. So, you know, we're going to try for 2 years, but if it's 3, don't, you know. With that, I just want to ask all of you for your support in our efforts, not just in the Indian River Lagoon, the Upper Basin, all of our restoration efforts. We're all hopefully on the same page here, moving towards the same thing, wanting to have a vibrant, healthy ecosystem so that we and our children can enjoy it long into the future. We know that population is going to continue to grow over the coming generations, and if we can put some things in place that guarantee a lifestyle for the future so that we all can enjoy it, I think that's critical, because we've got to somehow keep what we have here and not let it degrade. And with that, I'd be happy to answer any questions about this, about the Indian River Lagoon Protection Initiative, or anything else you'd like to ask. I think everyone's hungry.
That's a good thing about being right.
Well, I was hoping for that, yeah. All right, with that, I'll thank you very much.